Okay, so expanding brackets, fairly simple. So we've got x to the minus 2, y to the minus 2, x squared, y to the minus 1. Take x to the minus 2, y to the minus 2, y squared, x to the minus 1. Let's add these indices. So we get x to the minus 2 plus 2 is 0, y to the minus 2 take 1 is minus 3. Take x to the minus 3, y to the 0. Anything to the 0 is just 1. Y to the minus 3 is the same as 1 on y to the positive 3, 1 on x to the positive 3. So that was fairly simple. I can't write with that on. This one, 2 to the n plus 1 is the same as 2 to the n times 2 to the 1. Take 2 to the n over 2 to the 2n times 2 to the 1, take 2 to the 2n. I'm going to factorize top and bottom. So on the top, 2 to the n goes into both of these. 2 to the 1 is left over, 1 is left over. Here we've got 2 to the 2n in both of these, 2 to the 1 minus 1. So 2 to the 1 is just 2, take 1 is 1. So we've got 2 to the n over 2 to the 2n. Now, this is the same as 2 to the n minus 2n. n minus 2n is negative n. So we've got 2 to the negative n, which is 1 on 2 to the n. Yep. Fully simplify this one. So because we've got 3 to the n and 2 to the n on the bottom, I want to express everything in terms of those. So 12 is the same as 2 squared times 3, because it's 4 times 3. To the n minus 18 is the same as 3 squared times 2 to the n. We're going to have it over 3 to the n minus 2 to the n. So this is going to give us 2 to the 2n, 3 to the n minus 3 to the 2n, 2 to the n over 3 to the n minus 2 to the n. What goes into both of those on the top? Well, 2 to the n does and 3 to the n does. So 2 to the n, n plus n. So we've got 2 to the n left over and 3 to the n left over here. 3 to the n minus 2 to the n. Now, these are really similar, but the signs are different. So I'm going to chuck a minus. That makes that 3 to the n take 2 to the n, or negative 2 to the n plus 3 to the n. Over 3 to the n take 2 to the n. Now we just need to cancel. So we've got negative 2 to the n, 3 to the n. And that's that simplified. And they've put that together, which means we've got negative 2 times 3 to the n. I just took the negative out the front. I can't bother dealing with it, which means I've got negative 6 to the n. Fully simplify this. Oh, okay. So we've got x to the 5k plus 1, y to the 4k take 5 over x to the, I'm going to expand those brackets, 2k take 2, y to the negative 2k plus 1, and this is all to the third. I'm going to deal with the to the third at the end, which is the same as x to the, I've got 5k plus 1, and I'm minusing off 2k take 2, y to the 4k take 5, and we're minusing off negative 2k plus 1, and it's to the third, equals. So we've got x to the 5k take 2k is 3k, positive 1 take negative 2 is plus 3. Y to the 4k take negative 2k is 6k. Negative 5 take 1 is negative 6 to the third. And I'm going to factorize these exponents. So I've got x to the 3 outside of k plus 1. This is just to make my life easier in one step, because now I need to multiply both those powers by a third. So I've just got x to the, well, 3 times k plus 1 times a third, y to the 6k take 1 times a third. And as you can see, we're going to end up with x to the k plus 1, y to the 2k take 1. Fantastic. Okay. Let's work through these ones. It's all about trying to express these logs in terms of log base A2, log base A3. So log base A4 is the same as log base A2 squared. Don't forget, we can move this one down the front, which makes it the same as 2 times log base A2. So that 2 became that one out the front. Log base A2 is m, so we've got 2m. Question B, log base A of 27. Now 27 is 3 cubed. So we've got log base A of 3 cubed, which makes it 3 log base A of 3, which makes it 3n. Question C, 1.5. We've got log base A. Now you should already be thinking that's 3 on 2, which makes it log base A of 3 minus log base A of 2, which makes it n minus m. Question D, we've got log base A of 12. Now that's the same as log base A, 2 squared times 3. So we've got log base A of 2 squared plus log base A of 3. Now we already know log base A of 2 squared, that's 2m plus n. Question E, log base A of 18. Well, this time we've got log base A of 3 squared times 2, which means we've got 2n plus m. And last but not least, F, log base A of 13.5. That's 27 over 2, isn't it? Which means we've got log base A of 27 minus log base A of 2. We already know the log base A of 27. It was 3n minus m. They're quite satisfying. Okay, this one is along the same deal. So log base A of B and C is the same as log base A of B minus log base A of C, which means we've got 2.75 minus 0.25, which means we've got sorry, I can't do the maths bit of this maths, which means we've got 2.5. BC squared means we've got 2 times log base A of BC, which means we've got 2 times log base A of B plus log base A of C, because C is B times C, and you can separate them out like this. So we've got 2 times log base A of B was 2.75, log base A of C was 0.25, 2.75 plus 0.25 is 3, 2 times 3 is 6. I like it when you do questions. It's worth 2 marks, and it came out as the number 6. Okay. This one, we are going to start off by splitting up these exponents. So we've got 2 to the log base 2 of 3 times 2 to the log base 2 of 5, which means 2 to the log base 2 of 3, the 2 and the log base 2, they cancel out. We've got 3. Same here, 15. Now, this one, we've got 2 to the x equals 7. It's going to be easiest to take the log of both sides, and we may as well do the natural log. You could do the log base 10, doesn't matter. So ln 2 to the x equals ln 7. Take the x down the front. We've got x times the ln 2, ln 7. So we've got x equals ln 7 over ln 2, and we chuck it in our calculator. 4 significant figures. So we've got 2.80735, etc. 4 significant figures is 4 numbers from the first. That's not 0. And round if you need. Okay. Now 3 to the 2x is the same as 3 to the x squared. This should be looking a lot like a quadratic for you. So if we've got 3 to the x equals u, then we've got u squared take 12u plus 27 equals 0. 2 things that multiply to give 27, add to give negative 12. Negative 3, negative 9. U take 3, u take 9, which means u equals 3 and u equals 9. Now that means 3 to the x equals 3 and 3 to the x equals 9, which means x equals 1 and x equals 9 is 3 squared, so x equals 2. Okay. If we have log base 3 of x squared equals log base 3 of 6 take x. Now, I'm pretty sure we can go straight to x squared equals 6 take x, but let me go the long way because it's been a while. Let's get them both over to the left. We've got log base 3 of x squared take log base 3 of 6 take x equals 0, which means we've got log base 3 of x squared over 6 take x equals 0. So 3 to the 0 equals x squared on 6 take x. 3 to 0 is 1. Multiply by 6 take x. Yeah, we've got x squared equals 6 take x. So that's the long way for this lovely shortcut. Now let's get everything over to the left and solve. X squared take plus x take 6 equals 0. 2 things that multiply to give negative 6, add to give positive 1. Positive 3 and negative 2. So x equals negative 3 and x equals 2. But of course, you can't take a log base 3 of a negative, because 3 to the anything can't come out as negative 3. Like 3. So x equals 2 is our only answer. So with logs, you've always got to go back and double check. Sketching. These are fairly simple. Think of transformations. You always want to put on your intercept and you always want to chuck in another value. It's always easiest to chuck in x equals 1 as the other value. So your intercept for most of these, it's going to be 3 to the 0, which is 1. Anything, it's going to be 1. Then your next value, if we chuck in 1, 3 to the 1 equals 3. Question 2, 3 to the minus x, just means that we're going down this way. So we've got 1. Technically, you could have 1 and 3 to the minus 1 would be 1/3. Or you could have just been lazy and been like, well, that's minus 1 and 3. Question 3, 10 to the x. This is still 1. Our next one is 1, 10. 10 to the 1 is 1. Question 4, 1/6 to the x. This time, this is still 1. Our next value is 1/1/6. Question 5. 2 to the x take 1. Now this time we've been moved right 1. So if we chuck in 0, 2 to the 0 take 1 is a half. If we chuck in 1, 2 to the 1 take 1 is 2. No, 2 to the 1 take 1 is 1. Thank you. I'm here all week. 2 to the x minus 1, we've just moved down 1 this time. So you'll find that if you do 2 to the 0 minus 1, it's going to come out as 0. Oh gosh. 2 to the 1 minus 1 is going to come out as 1. And question 7, 1 minus 2 to the negative x. Let me write that down. Well, let's find our y-intercept. 0. When x is 1, y is 1 minus 2 to the minus 1, so it's going to be a half. When x is negative 1, we're going to have it's going to kind of look like that, but better. If I want to figure this out by transformations, I think that's a better way. Can I give me another color? Okay. 2 to the x is going to look like that. 2 to the minus x is going to look like that. Minus 2 to the minus x is going to look like that. But we've moved it up 1. One minus 2 to the minus x is going to look like that. And the values as before, 0, 1 half, negative 1, negative 1. Okay. This time we're sketching a whole bunch of logs. Don't forget, log just tends to look like that. And then chuck in x equals 0 to find your first, well, not x equals 0, y equals 0. To find your x-intercept. 0 equals log base 10 to the 2x. So you're always going to have 10 to the 0 equals 2x, or whatever to the 0. 1 equals 2x, so x is a half. So that's that point. Half comma 0. And then let's chuck in x equals 1. Y is going to be log base 10 of 2. That's not going to give us anything nice. Yep. If we do log base 5 of x squared, this time for our, it's still going to kind of look like that because we're not putting anything too accurate in. Let's find our intercepts. So we're going to have 5 to the 0 equals x squared. So 1 equals x squared, x equals plus minus 1. Oh, but we can't have the negatives. And if we just sub in x equals 5, for example, log base 5 of 5 squared is going to be 2 times the log base 5 of 5, so it's 2. So it's actually just going to kind of go really flat. Number 3, log base 6 of 3x takes 6. Again, y-intercept. We get 1 equals 3x takes 6. 7 equals 3x, so x is 7 on 3. Etc. Chuck a few extra points in. Gosh, these get really annoying very quickly. Number 4, look, they're all just going to kind of look like that. This one's not in the scope of the course. Log base 7 of negative x. This time it's just going to kind of go like that instead of that. Okay. When we're sketching e to the x, it's really similar as anything else to the x. Zoom. It's always going to go through the point 1, 0. Not y-intercept, x-intercept, y equals 0. 0 equals log base e to the x, so e to the 0 is x, so 1 equals x, etc. And then let's point in another point. Let's put in the point x equals e. Y equals log base e of e, y equals 1. That'll do. On the same sketch, find graphically the number of solutions to the equation. Log base e of x take x equals -2. So log base e of x take x equals -2. This is going to be the same as finding when log base e of x equals, move the x over and we get x take 2. Sketching x take 2, okay. It's going to look like that. So we're going to have 2 solutions. And we haven't been asked to find how many, what the solutions are. We've just been asked to find how many solutions we have. So we didn't have to be very accurate with this at all. Okay, back into these ones. This is a comfort zone. I really like these types of questions. They're fairly simple. Okay, so given that Q equals half Q naught, when T equals 1690, calculate the value of K. So they've given us the half-life. So we know when T equals 1690, we've got half Q naught equals Q naught e to the minus K times 1690. Get rid of the Q naughts. So we've got half equals e to the minus 1690k, which means ln half equals minus 1690. So k equals negative ln half over 1690. which is approximately 0.00040101, etc. We're going to leave it as this for any future calculations. Aye. After how many years does only 20%? So Q equals 0.2 Q naught. So 0.2 Q naught equals Q naught e to the minus k t. I'm going to substitute this in. I'm not going to bother writing it out now though. Get rid of the Q naught. So we've got ln of 0.2 equals minus kt. So t equals ln of 0.2 over minus k. So t is, and I'm just going to chuck that straight in my calculator, ln 0.2 over minus answer 3924.06 years. I love those questions. They always give them slightly too many marks for the amount of effort it takes. 10 kilos of sugar, yada, yada, yada. We're given something, we can find K. Now, when T equals 4, A equals 3.2. So we've got 3.2 equals 10e to the minus 4K. Let's solve it. 0.32 equals e to the minus 4K. ln 0.32 equals minus 4K. So K is -4 on ln 0, wait, other way around. Negative ln 0.32 on 4. So K is approximately 0.32 on 4, 0.2849. After how many hours does 1 kilo of sugar remain undissolved? We started with 10, we've got 1 left. E to the minus kt. So 0.1 equals e to the minus kt. So ln 0.1 equals minus kt. So t is minus ln 0.1 on k. Hopefully you still have that answer in your calculator. ln 0.1 on k on answer, 8.08 hours. And using the DMS button, degrees, minutes, seconds, that's 8 hours, about 5 minutes. Okay. Layer of plastic cuts out 15% of the light and lets through the remaining 85%. Show that 2 layers let through this much of the light. Whenever we talk about intensity of light, we should start thinking of it as I want to dive in and treat it like an exponential, but my brain's screaming logarithmic at me, and I just want to know. So 1996, mathematics, 2-unit HSC. Which column is it? My apologies. Second from last. And which question is it? Question 3. Oh, let's just have a go treating it as an exponential. So let's do a equals a naught e to the minus kt. T will just be the layers for this question. So a naught is 100%. When t equals 1 layer, a is 0.85. So we can say 0.85 equals 1 e to the minus k times 1. So ln 0.85 equals negative k. So k equals negative ln 0.85. Assuming this is the case, then t equals 2 layers. A equals e to the minus k times 2. So a equals e to the minus negative ln 0.85 times 2. So to the minus negative ln 0.85 times 2. 72.25%. 0.7225. Hooray! My first instinct was correct. How many layers are required to cut out at least 90%? So 10% remaining. So 0.1 equals e to the minus k times t, which we've got t is the number of layers for this question. So ln 0.1 on minus k equals t. So t equals ln 0.1 over minus negative ln 0.85. The negatives cancel out. There's really no use having negative in that thing. It's convenient, I guess. We've got ln 0.1 over ln 0.85 gives us 14.168 layers. Now we want to cut out at least that much, and we can't have 0.168 layers, so we will need 15 layers. Okay, this one, let f of x be that. Show that f of x times f of negative x, yada, yada, yada. Okay, f of x times f of negative x is 1 plus e to the x times 1 plus e to the minus x, which is, expand those brackets, we get 1 plus e to the minus x plus e to the x plus e to the x e to the minus x, which gives us 2 plus e to the minus x plus e to the x. Now, f of x plus f of minus x is the same as 1 plus e to the x plus 1 plus e to the minus x, which gives us 2 plus e to the x plus e to the minus x, which is the same as f of x times f of minus x. Wow, that was a HSC question. 2 marks. Nice. There's always some low-hanging fruit there. It's not always at the start, but it's always present. Okay, we've got an equation for the intensity of sound. The loudness of sound is 110 decibels, find the intensity. So for I, we've got I equals 10 to the minus 12 times e to the 0.1 times 110. We want to give our answer in scientific notation, so I'm banging that straight out in my calculator. So we've got 10 to the negative 12 times e to 0.1 times 110. That came out terribly, so I'm going to press the E and G button, which gave me 59.874 0.414 times 10 to the minus 9. That's not scientific notation though, because there's two numbers in front of the decimal point, so I just have to move it one over. I'm moving it one left, which means I need to compensate for that. So it's 5.98741 times 10 to the minus 8 watts per meters squared. Question II. Here damage occurs if the intensity is bigger than that. So we need to just solve 8.1 times 10 to the minus 9 equals 10 to the minus 12 times e to the 0.1 L. To get rid of the 10 to the minus 12, we get 8.1 times 10 to the positive 3 equals e to the 0.1 L. Or you could have just chucked it in your calculator. So ln 8100 equals 0.1 L. So L is ln 8100 over 0.1, which makes it 10 ln 8100, 89.996 decibels, so approximately 90 decibels. Number 3. By how much would the loudness have increased if its intensity has doubled? So let's say I naught equals 10 to the minus 12 times e to the 0.1 times L naught. If its intensity has doubled, that means and this is a new L. We've got to find this new L, and we're going to find it in terms of L naught. So we've got 2 times 10 to the minus 12 times e to the 0.1 times L naught equals 10 to the minus 12 e to the 0.1 times L. So we can actually get rid of those 10 to the minus 12s. We've got 2 e to the 0.1 times L naught equals e to the 0.1 times L. Let's ln both of these. ln 2 times e to the 0.1 times L naught equals 0.1 L, which means, have I just completely confused myself? Whatever, I'll keep going. ln 2 plus ln e to 0.1 times L naught equals 0.1 L. ln 2 plus 0.1 L naught equals 0.1 L. Yeah, I've just really confused myself. Question 10. Nope, I'm on the right track. Get rid of those 0.1s, divide by 0.1 is the same as timesing by 10. 10 ln 2 plus L naught equals L. So which means L take L naught equals 10 ln 2. So for it to have doubled, it must increased by 10 ln2. Okay. Termites, hooray, yada, yada. T equals 0. Number of termites is that. What is the value of A? So T equals 0. We've got 3 times 10 to the 5 equals A on 2 plus E to the minus 0. So we've got 3 times 10 to the 5 equals A on 3. So A must be 10 to the 5. Easy mark. 1 month. So T equals 1. N of 1 is 10 to the 5 over 2 plus E to the minus 1. So we have approximately 42,231.88 termites, which is about 42232 termites. And number 3, how many termites would you expect to find in the mound when T is very large? So as T tends to infinity, E to the minus T, as T gets bigger and bigger, that particular term tends to 0 because it's to the minus T. So it's 1 on E to the T. So we're going from a big number to a small number. So A on 2 plus E to the minus T, well, A is 10 to the 5, is going to tend to 10 to the 5 over 2 plus 0, which is 50,000 termites. So you can't fit more than 50,000 into this mound. Oh, that's the end of this one. Well done on making through another section, or your first section, if that's the case. And at some point, I will figure out how to end.